To our spot. Good evening to all our spot qualifiers. Welcome to your second session of the VSSF Spot Virtual Classrooms. We are so glad to have you back with us today. Before we proceed, the housekeeping rules, which I ran through even during our first session. Kindly note that questions from this session could be part of your spot final exam. All right, so ensure that you are actively participating and listening and reflecting on whatever is being presented during our session today. And a humble request to refrain from posting the same messages or the same queries in the chat box. Kindly ensure that every query that you post in the chat box is related and relevant to our topic at hand so that our speaker would be able to answer it. All right. And as always, I hope you enjoy our session today. We'll move into the introduction. Our topic for today is entitled Earth Science, Its Relevance and Impact in Daily Life. Now, Earth science is, I'm sure you all know, it is the study of the Earth's structure, properties, processes, and 4.5 billion years of biotic evolution. Now, understanding these phenomena is essential to maintenance of life on the planet. The expanding world population demands more resources, it faces an increasing loss from natural hazards, and releases more pollutants to the air, water, and land. So sustaining our existence requires scientific understanding of the natural materials and processes linking the geosphere, hydrosphere, atmosphere, and biosphere. Life prospers or fails at the surface of the earth where these environments interact. Now, the knowledge gained and the services provided by Earth scientists help us as a society to cope with its environment in many, many ways. Our scientists' knowledge of the structure, chemical composition of the Earth's crust would help us locate resources that sustain and advance our quality of life. Understanding the forces in the crust and the natural processes on the surface would allow us to anticipate natural disasters such as volcanoes or earthquakes, and geologic environments such as damaging mining practices or improper waste disposal, to name a few. So a comprehensive perception of our earth sciences will help us better deal with our environment, to take better care of it so that we benefit and we don't harm our earth as a result of all our technological advancements. Based on this, I would like to introduce our keynote speaker for today, Dr. S.K. Varshni, who is the scientist and head of the Department of Science and Technology, Government of India. I would quickly like to run you through some of the very, very accomplished. I'm sorry, is my voice breaking? Hello?
Oh, it's fine. It's fine. Please carry on.
I'm sorry, I think my connection was unstable. Am I audible now?
Yes, you are.
Yes.
Okay, all right. Thank you, sir. Thank you, Suhasini. Yes, so like I was saying, I'd like to introduce you all to our keynote speaker for today, Dr. S.K. Varshni, who is a scientist and head, Department of Science and Technology, Government of India. Mr. Varshni is a scientific officer with the Government of India who works with the Ministry or Department of Science and Technology. He has been working with the department since 1990, facilitating international scientific cooperation of India from the department with its bilateral, multilateral, and regional scientific partners. He has worked as a counselor with the Embassy of India in Moscow to facilitate bilateral scientific cooperation between India and Russia during April 2008 to June 2011. He has also been contributing to the promotion of international scientific cooperation as well as scientific industrial cooperation. He completed his MSc in Geology in 1984 from Aligarh Muslim University and was awarded the University Medal for obtaining the first position. He also pursued a doctoral research at the University of Delhi between the years 1985 to 1990 on Himalayan river systems, sedimentation, diagnetic and tectonic modifications. He qualified for the UGC NET in 1985 for the Junior Research Fellowship and Lectureship. He was also awarded the Dr. D.N. Wadia Research Fellowship in 1986 for his research on the Himalayan geology. He is also a Life Fellow of the Geological Society of India in Bangalore, the Nepal Geological Society, Kathmandu, and member of the International Association of Sedimentologists at Oxford. Apart from all of this, he also has numerous certifications to his credit, and he has also been a lecturer at Kurukshetra University in 1990. Sir, it's an absolute privilege to have you spend time with us today. I hand over the session to you. Thank you so much for joining us.
Thank you very much for the introduction and for the invitation and for the interaction with my young friends. And congratulations to all of you for a qualified spot round 1. So it is already a kind of achievement that you have been filtered and you have come to this stage. So if you can unshare your screen, then I can probably share my screen. Yeah, thank you very much.
Sure,
today we are going to discuss about this planet Earth and how it could be, what it holds for us, and how we could see various processes that are taking place and how it goes on. And there, in the first part, we will discuss about the processes, and in the second part, we will discuss about some of the beautiful landscape we could see on the Earth's surface. I think all of you know this particular picture. I need not to elaborate upon that. We are part of the solar system headed by Sun. We are number 3 in terms of distance from the Sun. We are the solid planet, one of the solid planets. And the uniqueness which we bring is that we are the only known planet to sustain life. Now, when I say life, it does not mean that only you and me, only human being. It means animals, it means fishes, it means reptiles, it means insects, it means plants, all trees, shrub, herbs, any kind of plants. So in any form, life is possible, at least so far. We know that this is the only place in our solar system to have life. Now, is there life outside our solar system? Of course, we have been discussing that if there is life outside our planet, in our own solar system, and so far we have got absolutely no clue. Of course, some of the planets have got water on their surface, which is one of the vital factor in sustaining life. Even on Earth, we are thankful to the presence of water, which makes life possible. And if I could say that life originates near the water source or in the water, that would not be very uncomfortable saying that. But so we require water, we require moderate temperature. And when I say water, it does not mean absolutely the cold water or frozen water, but we are looking for liquid water, what we say normal room temperature or something like that. So we have several conditions on this planet Earth which makes life possible. So including liquid water, moderate temperature, free oxygen in the atmosphere, appropriate sunlight. Now, remember that there are 2 other planets which are much more closer to Sun as compared to us, but they have very high temperature and they do not have oxygen. So the amount of sunlight, the amount of sun heat we get is moderate, and that is why life is possible here. And we do not have any toxic substance in our atmosphere. Of course, we are changing it with our day-to-day life. and we could discuss it little later. And then we do not have any lethal radiation. We are protected by ozone layer in our atmosphere. So these are several factors which makes Earth as a unique planet in the solar system. And as far as life is concerned, we are wondering if there is life in other galaxies. So like we are part of Milky Way galaxy, but is it possible that some other galaxy might have life? So still there is no concrete evidence. And then in the picture, the lower picture, I have tried to show you that how life could have begun on this earth. So just to understand how we look like from the surface, there are three parts: lithosphere, hydrosphere, atmosphere. I think you might have heard about them. Lithosphere is the solid part of the earth. Hydrosphere is the water body all around, and then atmosphere, upper atmosphere, what we see on the sky. And these three together create environment which is conducive for the life, which we call biosphere. So biosphere is not a part of the earth, but overall the life system which is supported by earth is called biosphere. So first question what we could think about is, how is it so that when there is no life on other planets, why earth is unique and why it was signaled out to develop life? And when did it happen? What is the age of our own earth? When did the life started? How it got complex? Do we have all the species?
Excuse me, sir, if I may interrupt.
Yeah.
Yes, sir. Your slide is still on the first page.
Oh, it's not moving?
No, sir.
Now?
Yes, now it is. Now it is.
Okay, let me just reduce this part so that you can see more of it.
Would it be possible for you to present it on full screen, sir?
No, I was trying that, but then you are saying it's not moving. Do you see this slide?
Where did all the water come from?
Yeah.
Yes, sir.
And is it moving now?
No, sir, it isn't.
No, that is a problem. I'm so sorry, but you may have to compromise because I cannot do much. But fortunately, there are very few slides with more of text, which is more of pictures. So I think we can manage.
All right, sir. All right, sir. No problem at all.
Yeah. So question is, how did we get life on this planet and why we do not have life? So water was the first major factor which made it possible that there could be life on this planet. So Earth is believed to be have formed nearly 4.5 billion years ago. And when it was formed as a result of Big Bang, it was a dry, rocky planet. So there was no water on this planet and there was no life. And then we got several falls of asteroids which were filled with ice. Now, when ice is coming, they are coming from colder environments. And when this ice came to Earth, because of our moderate temperature, we started getting it warmer and warmer. So we had it in the liquid form. And once we started having it in liquid form, it provided a basis for the life to origin. Remember, the life started in the simplest form, like unicellular life. So we have a lot of amoeba and those kind of things which are unicellular. But then slowly and slowly, it started growing and it became multicellular. And then we had amphibians or aquatic animals, reptiles, and then we have achieved complex things like vertebrates, including all amphibian and this thing. Initially, unicellular, multicellular, invertebrates. Then we got vertebrates, and in vertebrates also life started in the sea. So aquatic, amphibian, and then terrestrial animal came, and most of the mammals are much later developments. Now, question is whether all these species are constant or are living. I think all of you know that several species have been wiped out from the earth since its origin, and the most famous one is dinosaurs. So you knew the dinosaur came here on this earth nearly 200 million years ago and disappeared 65 million years ago. Now, it is very interesting that when we are talking about earth, we are talking in terms of million and billion. Like earth was formed 4.5 billion years ago. Dinosaurs were here 200 million years ago, disappeared 65 million years ago. So you can imagine that if we have to count human life, maybe 100 years, then how long it will take, how many generations would have taken since we came. So, of course, on this planet, we are nearly 10,000 year olds, our species, 10,000 year old, but processes of Earth are very, very slow, and it takes a lot of time to achieve anything. Now, just to give you an idea, like Mount Everest is getting its elevations higher and higher in the order of about 4 millimeter for every 100 years. So you can imagine that how slow are the processes, and normally they are unnoticeable by the naked eyes. I think all of you are familiar with this picture, how water comes on the surface and how do we make good use of this. So this is the water cycle, that it lot of water flows down to the ocean, then it is evaporated, condensation, and then again in the form of precipitation we get it. Now, just to give you an idea that if this is the total water, only 2.5% of the total water is fresh water. So remember, when we say that a major part of the Earth's surface has got water, but still we have got only 2.5%, which is fresh water. And if we talk about fresh water, most of it is frozen as a glacier in permafrost region. And some of it, nearly 30%, is in the groundwater. And very little is what we are calling as surface and atmospheric water. Now, surface and atmospheric water means water you see in lakes, water you see in the rain, water you see in the river or other water bodies, and like that, and in the air moisture, clouds. So that water is very, very limited. Groundwater, again, is a very, very subjective issue, because in several cities, we have got notice that they have overdrawn groundwater and groundwater is no more available. So including cities like Delhi, Mumbai, Bangalore, Gurgaon, there are several cities, several Indian cities, not only Indian cities, but for example, you might have heard stories from South Africa, where they do not have groundwater. So you may be covered or you may be approximated by a sea or a ocean, but when it comes to the groundwater, you are having very little of it. So we need to make judicious use. We need to harvest rainwater so that groundwater remain recharged and we make good use of it. Now, when we are coming to surface water, so most of it is in the form of lake, then air moisture or in atmosphere, and then other water body. River has only 1.6% of the total fresh water in the system. Now, second criteria, what we needed was oxygen, because that is another important element for life to be supported on this planet. And nearly 2.4 billion years ago, when the first life started, the initial creatures were microbes. I think you might have heard microbe in recent times. We are all affected by a microbe, which we are better calling as COVID virus. So virus we can't see. So these are very, very small creatures. You can see normally under microscope or under magnified lenses. And there used to be a cyanobacteria, which is releasing oxygen as a waste product. Now, let us come back to today. We know that for our survival, we need plants. Why we need plants? Because nature has created a system. What is considered waste by the plant is used by us. And whatever is considered waste by us, or whatever is exhaled by us, is absorbed by the plants. So there is a natural balance which nature has created. So oxygen which we need is discharged by the plants, and they need carbon dioxide to make their food, which is released by us. So this is an automatic balance. So what happened nearly 2.4 billion years ago? This microbe started getting formed, and they were releasing oxygen as a waste product, filling atmosphere with nearly with oxygen. Now imagine Earth was formed 4.5 billion years ago, and this form of life, cyanobacteria, 2.4 billion years ago. And slowly it started adding oxygen to the atmosphere. And it took time. And we realized that first life, major life, got formed on Earth's surface nearly 540 million years ago. And since then, we are maintaining it. So this is just a slide to show you the oxygen balance. So not oxygen balance, the carbon balance. And carbon is consumed by the plants for the photosynthetic processes, and also absorbed by the seawater. Whereas we are releasing it through variety of sources. So there are some natural sources like volcanoes, like our respiration processes, but then there are a lot of anthropogenic activities like we are use of our auto vehicles, use air discharge by our factories, which are adding up. So what is happening? We are saying that this may disturb our carbon cycle. So as long as the processes are natural, so if only from natural sources we are doing it, it is fine. But if we are discharging any particular gas, in this case carbon, and we are adding up carbon, then it would happen that we may become toxic very soon. So something important in the history of Earth we are calling is Cambrian explosion. So that was a time when life had been consisted in the form of bacteria, eukaryotes, and simple plants. And this period, Cambrian, marked this boundary that before that it was only simple life, but Cambrian period, which started nearly 550 million years ago, started having seen life which had brains, eyes, and skeleton. And these are mostly invertebrate. So availability of oxygen, earth temperature, and development of shallow aquatic environment contributed for this thing. Now, just to have a look on our atmosphere, we talked about oxygen and carbon dioxide, but there are two more things which are worth noticing. One is that temperature in the atmosphere is not moving in one particular direction. There are several atmospheric layers, and at each layer, when we go up, when we go high away from the Earth's surface, higher and higher, so either temperature starts increasing or decreasing. So like what we see from our home, we are normally seeing troposphere, which is the lowest layer of the earth, which has got all kind of disturbances, all kind of smokes, everything. And here temperature keep rising as we go up. And then we have got a boundary which is called tropopause, beyond which we have got stratosphere. And this is where the flow of air is laminar, uniform, and there is no disturbance. And this is where we will see most of our flights would be operating. And when we go to top of stratosphere, we have got another boundary called stratopause, and then we have got mesosphere. And mesosphere has got most of the asteroid faults that are coming, they are absorbed here, reduced to ashes before they are gifted to Earth's surface. And then we have got the top layer is called thermosphere, and it is also quite interesting because we have a very unique phenomena here, which is called aurora. Just to see that what is aurora, aurora lights you can normally see on the poles, and these are very, very specially attracting, and you can see both on the north and southern poles, in also in countries which are very, very close. These are natural display of light which is seen in high altitude regions, and aurora display dynamic pattern of brilliant light that appears as curtain rays, spiral, or flickers. And it is primarily because of ionization and excitation of atmospheric constituents that emits light. Now, that was the higher side, but when we come to the interior, the surface where we are standing, there's a lot of earth below us. And what we have concluded based on several geophysical activities, that we have a huge landmass below us, which could primarily be divided into three parts: earth crust, earth mantle, and earth core. Earth crust is solid. It could be of a thickness of 5 to 10 kilometers, and it is mostly a platform which is full of silica and aluminum. Mantle, on the other hand, is something which is in between solid and liquid. We call it molten state, and their temperature is very high, pressure is high, and then lot of things are in liquid form. And if you see some of the volcanoes, including one picture which you saw in the beginning when you were being told the house rules, it brings out materials from mantle. So when we are talking about volcanoes, it brings in material from there. And then we have got core. So mantle is liquid, semi-liquid, and is called primarily silica and magnesia. And core is the main part of the earth, which is full of nickel and iron. Now, question is, how do we know what is the thickness of each layer, and whether we have got only these three layers, or how, because nobody has gone inside the earth. Nobody knows that how it should look like, what should be the mineral composition, what should be the rock constituents, and how it should be. So all the information which we have got is through indirect methods. Direct method, of course, when volcano erupts, they show us, they are the window of the earth interior, and they will show us what kind of material it is, and that help us whenever we are making indirect studies. So indirect way, what we are doing is that we have studied earthquake. Earthquake has got two kind of waves, primary waves and secondary waves. And with the differentiation in their flow pattern, we can realize what is inside. Is it uniform? Is it not uniform? If it is solid, liquid, or gas? If it is, then what could be its thickness? And we have experimented this thing on several mineral deposits. So identification of mineral deposit, seismic surveys, or some other geophysical surveys help us a lot in defining the load. Load is primarily what we are saying in normal language, the what amount of mineral deposit they have got in a particular location. So geologists are not magicians who can tell you where you will find oil, where you will find gold, where you will find coal, where you will find copper or zinc or iron. So it is based on several geophysical and geochemical studies. So as far as structure of interior of the earth is concerned, it is primarily based on geophysical studies which we are making use of. Now, Earth is a very, very dynamic planet, evolving planet. It is not same at all the places. So you will find that Agra is different from Coimbatore, or Chennai is different from Mumbai. Similarly, you will find several processes happening on the Earth's surface at the same time. Somewhere it is snowing, somewhere it is very harsh winters or summers, somewhere it is raining, somewhere it is dry, and it all happens at one time. So, and it keeps changing the life form. Life form, as we know, from where we started and where we are. So from unicellular to complex. One thing is associated with all this evolution, that is, if climate is changing, and whether it has happened in history of Earth that climate has changed. If we go by Earth history, yes, it is possible, and there are several episodes of climate reversal. There are, but as I said earlier, natural processes are very, very slow. So what we are worried when we discuss about carbon cycle also, that how much of it is because of human endeavors, how much we are contributing to the disbalance of gases in our atmosphere, and will it fasten the process, or how we'll get it. So this is some of the occurrence of the Earth's surface, and you will feel that all days are not same, and sometime, somewhere, some part of the world will get an earthquake. So this is a picture from Bhuj, where we got a massive earthquake in 2001, and you will see that building could, very high-rise building could get damaged. Not only buildings, but even railway lines could get changed. Not only railway line, even river track could get changed because of earthquake. So there are several possibilities when earth energy is released, and it causes several deformations. Now, another form of release of energy is following earthquake is tsunami. Now, I hope some of you have already seen or heard about the tsunami that is struck in India also. It is very common phenomena in Japan. What happens, as we saw in the previous picture, that when earthquake comes on the land, it normally damages the buildings or the outer structures. And because of outer structure damage, there could be some life loss also. But when earthquake strikes in the sea, then the energy is released, and because of that energy, water starts flowing in a huge, in a big way and causing tsunami. And it could rise several meters over the normal water flows. Then another example of earth expression or earth release of energy is volcanoes. So this picture is from Andaman, and you can see some smoke coming out of it, but molten material also comes out of it, and it all depends that how it happens. So scientists have tried to studies that what are the earthquake sites and what are the volcanic activity sites. And these are volcanic site activity sites are called ring of fire. And you could see that while they have nearly 70 to 80% overlap. So if you see our Himalayan region, where we'll see a lot of tectonic activity, but no volcanic activity. But in a major other part, you will see that we could correlate earthquake and volcanoes happening at the same places, and which shows that those are the weak places from where Earth find it easy to release the energy. Now, what has happened because of this several activities? There is a theory which says that we were not the same all the time, and our continents, what we see in the map today, they were not like that in geological past. And there are evidences that continents have moved, and how it has moved. So one first explanation was that if we see their boundaries, the continent boundary, then they could be fitted one over the another as a jigsaw puzzle. And then came the theory of plate tectonics. Now, plate tectonics means that the entire continent is divided into several plates, and each plate is floating. So if we see here, you will realize that boundary of plates is much bigger than the continent, and it is spread all over the sea. So if it is African plate, its boundary are much, much bigger. Then Indian plate has got boundary up to here. And what is happening? Indian plate, which was in southern hemisphere, it has moved northeast. And today we are completely in northern hemisphere. And origin of Himalaya also is because of collision between Indian plate and Eurasian plates. So what is happening that Eurasian plates are here, Indian plate is striking, and because of this, it is rising like this. So this is because of this, we are having Himalaya, but then these boundaries, it could happen that there are a lot of movements, lot of disturbance at the plate boundaries, and earthquakes and volcanic activities, we will notice that most of them are near the plate boundaries. Now, what are the other evidence of movement of continents? So you will see that one major evidence is the fossils. I hope you are aware, fossils are the lives which are no more there, but only through their skeletals or their impression we try to study. And then we see there are several animals which are found in more than one region. So for example, today, if you see elephants are found in India and South Africa. So whenever the species elephant started was formed, that time India and Africa must be together. And there are several fossils which we have tracked, and in this slide we have tried to show how it is formed. Another major important thing which Earth has got is Earth magnetic field. So as I said earlier, the core of the Earth is full of nickel and iron, which results into the magnetic property of the Earth. Of course, we have made use of this property also. And today, lot of navigation is happening with compass, where all air movement, even today, our car movement, which we are taking help of Google Maps or any other navigation device, which keeps on telling us how to move, which direction we can go. And that is where uh, geomagnetic property of Earth help us. But one thing we should remember, that there is a difference between geographic north and magnetic north. So we keep on getting magnetic storm on the Earth. So magnetic north keeps on moving. And today it is at a distance of nearly 11.5 degree from the geographic north. Now, if you see Earth, you can see several parts of Earth having different conditions of the atmosphere, different condition of the soil, different conditions how temperature is there, and this is a series of them. So this is the first slide. I'm just showing you. You can correlate it with one of your place, and then this is one of the cold places uh, which we find normally near the poles or in subpolar region. So like places like Canada, Norway, or Nordic countries, or Siberia in Russia, they are known to be like this. And of course, Antarctica. Sorry. And then some other part of the earth could be as dusty or as heated one like this. This is mostly in desert. Some of the areas are so thickly populated and having disturbances. And then this is a common site which we have. This is flood, and we lose a lot of life. We lose a lot of properties when our rivers get inundated, and it happens because of either cloud burst or very heavy rains or some burst of water bodies like dams. And another reason why we are having floods, that we are not cleaning river channel and we are polluting it with several things. So naturally, water, whatever it comes in the channel, it is not finding adequate volume in the channel and it gets flooded. Lightning is another major thing which is happening. Of course, in our part of the world, lightning is happening only during the monsoon period or the raining period. But then there are several parts on the Earth's surface where lightning happens virtually every day. Then these are very, very important structures called stalactite or stalagmite. And these are formed in the caves. When river flows through a water soluble surface, it starts dropping, and drop by drop, it these deposits are getting accumulated and giving shapes to such things. And one of the very popular such deposit is Amarnath caves. So you remember in each summer we are having a special jatha which is going to Kashmir for darshan to Amarnath, and this is nothing but the form of ice which results in formation of structure like stalactite and stalagmite. Now there are two terms. Stalagmite is something which grows from bottom to top, and stalactite something which grows from top to down. And now I'll take you on a very interesting journey. I'll show you some pictures that how Earth's surface in different part is. So one of the recent discovery is Siberian craters. Now this is found in the gray jumble of ice and clots in permafrost regions. So roots of the plant newly exposed around the rim shows sign of scorching. It gives some ideas of just how violently this hole in the middle of Siberian would have materialized. From the air, the freshly exposed dirt stand out against the green tundra and dark lake around it. The layer of earth and rocks exposed further inside the cylindrical hole are almost black, and a pool of water is already forming at the bottom. And this was discovered as recently as 10 years ago. Just a moment. Then I think I need not to tell you about Bermuda Triangle. There are a lot of stories already in the media, and I think this is one of the most discussed or debated topic. And it is believed that there are a lot of magnetic storms, and ships and aeroplanes get disappeared in this area because of these magnetic regions. Then this is a very interesting place called Crooked Forest in Poland. And here what is happening, that most of the trees you will see are not straight. And these are nearly 400 pine trees, which is located in West Pomerania region. And what is happening, that there is a 90-degree sharp bend northwards, and then a curve back to grow straight into the sky. This is very, very unnatural, and we are not sure how it has happened. So there are several interesting questions which are still unanswered, and these are one of those questions which need to be answered. Now, this is a richet structure from Sahara, and it looks like a very fabulous disk, but this is the result of erosion. I hope you have read in your classes about the erosion, which happens because of air, water, and heat. It could happen, and because of erosion, the top layers are chiseled out and they are removed in the process. And what we are seeing here in Sahara, this is because of continuous erosion, all the top layers have moved away, and you see only the bottom part, which is forming a circular rim. Then the blood falls of Antarctica. Whenever we think of Antarctica, we are thinking it of a white continent full of ice. But then there are some lakes, and these lakes, because of their mineral compositions, have got some color. And here we are talking about the Stellar Glacier and West Lake, which has lot of iron-rich material. And because of this has got red color, and it is called bloodfall. And then we have got Darwaza crater. Now, Darwaza crater is a place in Turkmenistan which is always on fire, and it is also known as Gate of Hell. And why it is always on fire? Because this is a methane gas field, and somehow, purposely, because of military purposes, it was lighted, and it has remained lighted despite so many years. And today we find it, uh, it's a tourist place, but it is always on fire because of methane gas underneath. And then in New York, we have got something what we are calling as eternal flame, and you can see a flame uh, just below the waterfall. And this is because of the leakage of natural gases from the system. So it's a leak, and this leak has caused this waterfall to have this thing. And then we have got Fairy Circle in Namibia, which is another very interesting place. And here it's a huge grassland in the Namibia desert. And Fairy Circle are typically monospecific grassy vegetation where conditions are arid, and associated grasses commonly are species in the genus Stipa grostis. And study shows that these circles pass through a life cycle of 30 to 60 years. They became noticeable only when they grow in diameter 2 meters and above and achieving a peak. And then we have got this great blue hole in Belize near. Uh, it is because of several sinkhole operations. Uh, it's a reef structure. So reef have got surrounded it, and this water body has become receiving very little of fresh water. So most of the water in it is accumulated, and it is green. It is blue in. And then we have got this place in Indonesia, which is having volcanic activity inside the lake, and you could see the smoke coming out of volcanoes and the lake. Then we have got a beautiful structure in Lake Alberta, and this is humanly made, and you can see only in Canadian summers when what you are seeing below the water is the bubble of methane gas, which keeps on releasing from various time, and forms a very, very unique structure. And you don't find it during the winter time because it is frozen. And then we have got Lake Hillier, and you can see that a huge water body, the Indian Ocean. And then we have got a small lake which is red in color, and this is primarily because of the mineral compositions and the plants it has got in it. Then we have got Lake Maracaibo in Venezuela, and this is a place where we get lightning virtually every day. In fact, this is the place where you will get lightning maximum time in the world. So if you, this is a place you can study lightning. And then we have got Lake Nartan, Netron in Tanzania. This is highly alkaline. And when I say highly alkaline, it has a pH, its water has a pH value of 12. So any life here is not possible. So if any bird or any other animal falls in this water, immediately it gets petrified. And then we have got this Vadohu Island in Mauritius, and you will see a lot of light. Of course, there are some human activity also you can see, but our focus idea was to show you this light, which is coming from several sea animals. and we are calling it bioluminescence. So in night, you will see a lot of light emanating. I'm not sure if you have seen night fly in India called Jugnu, and you can see such lights from the waters, making it very, very attractive for the tourist purposes, and you will find it very interesting. So with this, I would like to close my talk today, and I would be happy to take some questions which may be summarized by the foundation, and we could discuss it. Thank you.
Thank you so much, sir. Thank you for such an interesting session. We will move on to the question and answer section right now. I will take questions that have come in through the chat box. Kindly ensure that when I call out your name, you introduce yourself, your class, and your school. All right, our first question is from Vijay Rohit. Vijay Rohit, can you kindly unmute your mic and pose your question? All right, we'll move on to our second question. Tamogna Srivatsa, can you please unmute your mic and pose your question?
Yes, ma'am.
Yes, please go ahead.
Sir, I have a question for you. What do you think would be an effective way to reduce pollution, especially air pollution, which can be done by everyone? I mean, people of all standards of life, as well as doesn't disturb our daily activities.
Thank you, Shreyans. I think it's a very, very interesting question. And all of us are worried that what we are leaving for the future generation as a earth. And today, if you see, we have polluted our air, we have polluted our water, we have polluted our land. And everywhere there are signatures of human activities disturbing or disbalancing the nature's creation. So if we talk about atmosphere, there is a lot of increase in carbon dioxide release from the surface, and there would be some consequences. If we are talking about rivers or water, we have overdrawn groundwater. We have given several kind of waste to the rivers. And when I say several kind, it is not only because of our water discarded from homes, but also from industries, which is full of chemicals. And that is going into this river water. Then if we see our, so question is that how we should make efforts to sustain the earth. So a lot of discussions are already in place, and you might have heard terms like COP discussions, which is basically climate discussions. There are several decisions like Kyoto declarations, Brazil declaration, the Rio declarations. And each time, a lot of new ideas are discussed how we can reduce. So for example, a lot of pollution is created by units using energy. And for energy, we are using either the hydrocarbons, which is coal, petroleum, diesel, gases, or we are using wood, which results in release of lot of carbon dioxide to the atmosphere. So what we are trying to do, we are trying, if in place of carbon-rich energy, we could go for some alternate routes. So now you might have seen in several bigger cities, we have started electric vehicle, which would be used based on batteries. And just like your phone, you would be charging them after substantial run. And once that run is done, so idea is that you will not be releasing carbon dioxide. But again, in formation of phone also, we are using a lot of carbon. So we are now talking about net zero solutions. So this is for the air. For water, we are trying a lot of biological interventions that before discharges from several sources goes and meet river water, the water should be treated in such a way that it does not damage river water. I'm not sure how many of you have seen river Musi in Hyderabad or river Yamuna in Delhi. The way they are treated, they have become something like drain. They are not no more look like rivers. They looks like drains. We have not seen Saraswati, river Saraswati. We know through our books it was there, and maybe in another 100 years or little more, we will not have Yamuna and Musi also, because the way we are putting all our discharge. So now coming to our approach, of course, we need to see that what kind of waste we are creating and how we are giving it back to the system. It should be our idea that we should not pollute. Now, how we are polluting? For example, we are at home, so we are giving soapy water. We should know where that soapy water is going. So it could be from our bathroom or from our kitchen, but wherever it is going, we should see how it is treated. Similarly, from the factory, I think it should be the responsibility of each industrial unit that they should get adequate treatment of their discharges. Whatever discharge they are releasing to the system, they should make sure. We should also look for water budgeting for our crops. Now, there are several regions, for example, in Punjab, which was typically a wheat-grown area, we have suddenly started paddy, growing paddy. And this means that this has caused more and more withdrawal of water from the groundwater. Similarly, in construction industries, lot of water is taken away. So we need to make cautious use of water, groundwater, so that there is an appropriate amount of it. And I'm sure that even our small steps would help us in improving the earth quality and in reducing pollutions. We can take biological roots of plants, which are our friends, and a lot of plants can absorb atmospheric carbon and even particulate matters. And we should see that we ourselves are not contributing to this effort.
Thank you, sir. Our next question is from Deepnil. Deepnil, could you kindly unmute your mic and pose your question? All right, we'll move on to the next student, Yash Agarwal. Yash, can you kindly unmute?
Ma'am, I was not allowed to unmute.
Okay, Deepnil, can you pose your question?
Yes. Good evening, sir. I was currently working on the Fermi paradox, and I would ask you that what are your views on the Fermi paradox?
Can you repeat your question?
Sir, I was working on the Fermi paradox, and I saw that it is quite counterintuitive what I found it. And sir, what is your thoughts on the or views on the Fermi paradox?
You know, these are considered to be some estimations about extraterrestrial life. As we all know that world over, lot of people who are trying to study origin of life, they are also studying if life is possible outside our planet, and if yes, where it could be. What are the uniqueness of Earth? Can we have a similar model on some other planet? But Fermi paradox is a conflict actually, because of lack of clear and obvious evidence for extraterrestrial life and various high estimate for their existence. So it is something we say not so easy, but of course, science survives on some hypothesis. You need to prove or disapprove. So Fermi paradox is one of them, and it discusses about possible life on other planet, maybe in our Milky Way or outside our Milky Way, somewhere in the celestial system. So this question even today is not fully understood, but as far as we know, we are unique. We are the only planet to have life.
Thank you, Deepnil. Thank you, sir. Our next question is from Madhimalar E. Can you kindly?
So my question was that why do we always look for the things that us humans or the living organism on Earth need, like water, nitrogen, carbon, and not look for life that could exist without them?
Oh, you see, let us, if I could say that we are very selfish people and we are very much worried about our life. So if you ask yourself whom you are most worried to, it would be you, then your family, then your bigger family or extended family, then your city, then your state and country, and then the earth. So unfortunately, we are not worried about life which can do without several of the parameters which are needed for human and animal life. But if you see food cycle, everything is important. And if we miss any element of the food cycle, it is broken. As we discussed in the beginning, when Earth was formed, there was no life. But because of oxygen release by cyanobacteria, it start and atmosphere becoming more conducive to sustain life, we started the Cambrian explosion where more developed animals started being formed. And of course, each animal, each species has a different requirement. Even in the plants, the requirement of various plants is different. So each species has their own unique set of requirements, and they could sustain only in a particular place. There are some animals, some plants which are known only for a specific region. They cannot survive outside. Human being has adapted itself. If you are living in Kerala, you can survive in Kashmir, you can survive in Russia, you can survive in Africa, you can survive in Antarctica, because we have developed tools for that. And we are very much worried about our life. And in order to keep our life on, it is important we allow biodiversity. Now, why? Another example you can understand why biodiversity is important is COVID. Now, if all of us on the planet would have been roughly the same, then the virus would have cleaned all of us. But because human beings on the earth are having different immunity level, different food habits, different clothing styles, different protection gears. Impact of COVID was different in different areas. Somewhere we were more cautious, somewhere we were less cautious. Can you imagine in a continent like Africa, which houses most of the poor countries, where still vaccination is not being done, we did not have amount of casualties as high as we had in America or Europe, which are claimed to be technologically more developed. It is because of the immunity level, because people in Africa had a better immunity as compared to people in Europe and in America. Similarly, if you see our own place, our animals did not suffer because of this thing. Of course, there are some reports that in cat family and in some dog family, so feline and canine, both have reported some kind of COVID infection, but not to that great extent. All other species are unaffected. So this is primarily because of biodiversity, and we must sustain it. So for food cycle, we need everyone. For our own survival, we need biodiversity. And let us welcome it, and let us, what would be happening to Earth if there is no life? It would be like another planet full of rocks and waters and no life. And that is possible also if we continue polluting it. Maybe another 500, 600 years, we may not have life. That is also a possibility if we are polluting it as much as we are doing now.
Thank you, sir. Our next question is from Madhimalar. Would you like to unmute your mic and pose your question? It is a very interesting question.
Yes, ma'am. So, sir, my question was that we've noticed that life has always seemed to adapt to ecological changes on Earth. So, would it be possible for us or other organisms to live in a CO2-rich atmosphere because of global warming? Maybe another event like the chemical event might occur?
I'm sorry, I couldn't get your voice. Can somebody repeat her question?
Yes, sir. I will read out the question.
Yeah.
The question is, we've noticed that life has always seemed to adapt to the ecological changes on Earth. So would it be possible for us or certain other organisms to evolve to live in a carbon dioxide environment?
Yes. So it's a very interesting question. You know, adaptation is the key. So we know if we do not adapt, we cannot survive. Why did we lose dinosaur? Because it is believed that there was a massive volcano eruption, which we are calling as a Deccan Plateau in our part of the earth. You see black soil. So because of that volcanic eruption, lot of dust was added into the atmosphere. And amount of dust was so high, it took nearly 3 years to settle in. That means that for 3 years, there was no sunlight on the Earth's surface. And many of the major lives, major species suffered because without sunlight, they could not get things like plants. Now, dinosaurs, although you have seen them in several recent movies, but most of them were herbivorous and they were eating plants. And if plants are not growing, they had no food for themselves. So adaptation is a key, and we have to find solutions. Now, of course, if our atmosphere become rich in carbon dioxide, what are the solutions? You might have seen already we have got home purifiers, home air purifiers, office air purifiers. We have started getting oxygen cylinders which could be put on each one of us if we live in an environment which is not good. Of course, nature will take time to make our bodies more susceptible to increased level of carbon dioxide. But for immediate support, we have already developed gadgets. Of course, their number is not that high, but there are solutions which we have kept. But nevertheless, we are trying that if we could return to Earth to its natural shape, that would be wonderful. Of course, if increased carbon dioxide is there for very, very long, say for very long period, that we do not get oxygen to be produced either naturally or synthetically, it would be difficult for human beings to survive on this earth.
All right, sir. Thank you. Ananya Srinath, would you like to pose the next question? Ananya, I've requested you to unmute, but you've muted it again. Yes, yes.
So do you think it's possible for humans to adapt themselves gradually to living in outer space or in conditions they're not familiar with? Because maybe we can alter our genes a bit to make the adaptation possible, like genetic modification. What do you think about that?
I request someone to say her question because audio was little poor.
All right, so Ananya was asking if what is your opinion on the ability for humans to sort of genetically modify themselves to survive in other conditions?
Oh yes, lot of experiments are on, and we are working on. As I said earlier, we are selfish. We would like to see human race surviving on this planet, whatever be the conditions. So not only this external gadgets of air purifier, oxygen cylinders, or some plants which we have discovered in recent past, which could produce extra oxygen. We are looking for devices which could help us sustain in highly carbon rich environment. And only thing I could say, of course, you can't beat nature, but we'll struggle if such a situation comes. And we will do everything possible. Adaptation is already on to the newer emerging situations. Gadgets are coming. So if we cannot live naturally without any external support, we can do it with the help of some support.
Thank you so much, sir. And our last question from today will be from Preeti Giriraj. Preeti, could you kindly unmute your mic and pose your question?
Yes, ma'am. Can you hear me, ma'am?
Yes,
Yes.
Preeti.
Probably we are not getting your voice.
Preeti, we are not audible right now. I've requested you to unmute your mic.
Ma'am, now can you hear me, ma'am?
Yes, yes, now you are.
Ma'am, yes, ma'am. Sir, good evening, sir. I'm Mitunya from Maharishi International School, class 9. So my question is, before Stephen Hawking dies, he said that within 100 years, the Earth is going to destroy. So in your point of view, what's the reason, sir?
You know, there are several stories and several assumptions, and several times people would like to make some ideas which may or may not be accepted by everyone immediately. So when Stephen Hawking was talking, he was talking in terms of various conditions which we have created ourselves, which are not good enough to survive. And he felt if we continue our activity in the same ways as we are doing now, without development of any solutions or without development of any correction, then we may have very limited life on this earth. Now, in past also, several people have tried to work out what could be the life of Earth as a planet. Now, as I mentioned a little ago, the processes of Earth are very slow, and 100 years is a very, very small time. Compare, we are talking about millions and billions of years. So I don't think personally that 100 years we may lose the human race on this planet, or the Earth planet will go. No, I don't feel that way. I feel it would be done very slowly, and if we correct ourselves, we can prolong our stay on this earth maybe for another thousands of years. So human beings are here since 10,000 years ago, and as you remember, it is only last 300 years since the industrial revolution started, when we started polluting our air, our water, and also agriculture contributed to it to an extent by withdrawal of various things like groundwater. So these are recent developments. So you compare Earth history, nearly 4.5 billion years, life on Earth, nearly 2.4 billion years, human species on the Earth for nearly 10,000 years. And what we have done in last 300 years is changing, but change is the nature of the earth, but it has expedited, it has hurried up. So we are concerned that it must be corrected, and if we could correct it or find solutions or could develop devices that will help us in survive in those conditions, our life on this planet would be little longer than 100 years. Thank you.
Thank you so much, sir. That brings us to the end of our question and answer session. Sir, on behalf of VSSF and all our participants, thank you so much for spending time with us. Like you said, towards the end, change is inevitable. Our planet will keep changing. We have to keep evolving. However, it is disturbing and distressing to know that the change is happening at a much rapid pace than what would be considered natural, if I may say so. And like you said, it is in our hands whether we can prolong this and slow it down and restore it to its natural cycles of change and evolution. Thank you so much, sir, on behalf of everybody for spending time with us. It was an absolute pleasure to have you.
Thank you all, and my good wishes to all of you. I hope you will find such session more curious, developing more curiosity rather than answering all of your questions. Science is that you should have more and more curiosity, more and more questions, and then you start exploring it, the answers, with the help of books and other study material, with the help of your teachers, your parents, and platforms like this Vikram Sarabhai Science Foundations. And I'm sure if you remain curious, curiosity remains inside you, and you work on those curiosity, you will become not only good thinker, but also a good scientist. My good wishes to all of you. Have a nice evening. Namaskar.
Thank you, sir. A humble request to all our students, kindly let us know what you thought of our session today. You can review us on Google, you can log on to our Facebook page and post your reflections or your queries or any questions that you have. Please ensure that you like, share, and comment, and even follow our pages if you haven't done that already. Your next session will be tomorrow. So you have two sessions tomorrow, your session, the third session and your fourth session. Your third session is at 2 p.m. and it's entitled Medical Science. Dr. Subramania Iyer, the head of the Department of Head, Neck, and Plastic and Reconstructive Surgery, would be your keynote speaker. And the session after that is at 4:30 p.m. entitled Astronomy, A Window to Space, and Dr. V.P. Joy, who is a scientist, the IAS Chief Secretary, Government of Kerala, and also an author, will be the keynote speaker. I hope to see you all at our sessions tomorrow. Have a good evening and thank you so much for participating in today's session.